now that we are going to factor this, we are going to use that greatest common factor that we already found, right? Okay. So we already found this over here. We had 12. Then we did the 1, 12, 2, 6, 3, 4, and we divided by 4a. So this goes out in front as our greatest common factor. Okay? So now we have to divide and we have to see what is left. Okay? So we are going to take 12 divided by 4 inside the parentheses, and that gives you 3. Whoops. And you have an a squared. That is 2 a's. A times a divided by a. So you have 2 and you divide by one of them. So how many do you have left? 1. So that's an a. Plus 16 divided by 4 right there. That's going to give you 4. And a divided by a, that just cancels out. That's taking out all the a. So your factoring gives you 4a times the quantity, 3a plus 4. And you could bring that other parenthesis in a little bit more, like this. Okay? Any questions about that? All right. Let's take a look at the next one. We've got 4 here to try. And we are always, when you are working with factoring, always look for a greatest common factor first. Okay? So let's look at A, which says 14g to the third plus 5g to the fifth. All right. So start with your smallest of your coefficients. Which one is smaller? Class? Which one is smaller? 5, yes. So when you have 5, what are the factors of 5? Well, there's only 1 and 5 because 5 is a prime number. Remember, primes are numbers that only have the number itself and 1 as its factors. So as I look, can I divide 14 by 5 evenly? No. So that means it's just 1. So yes, I am going to divide both of them by 1, but we all know dividing by 1 just gets you that number itself. So you wouldn't have to put it there, but for now, let's just put it there. All right, thank you to those that are keeping your phones away. I appreciate it. Then I have a g to the third and a g to the fifth. How many g's can I take away from each of them? What's the most I can take? 3. So that is g to the third. So divide by g to the third. This is your greatest common factor. And as the greatest common factor, it's going to go out in front as your first factor. And then you're going to put in parentheses what you get after you factor out that greatest common factor. So then we actually look and divide. 14 divided by 1 is 14. And g to the third divided by g to the third, do you have any g's left? No, because those simplify out, cancel out. I mean, you could put a 1 when you divide and you cancel it out, that's a 1. Plus 5 divided by 1 is 5. And g to the fifth divided by g to the third is... g to the fifth divided by g to the third is... How many g's do I have left? G to the fifth. You have 5 that are being multiplied. You're dividing by 3, so you have 2 left. So that is g to the second. Now, how could we check this and make sure this is right? you would just multiply it forward and see if you get the same answer. So this is the correct answer right here. That is your final answer. That is 14g to the third plus 5g to the fifth factored. All right? But to check it, you would take this and you would distribute. Well, 1 times 14 is 14. G to the third. 1 times 5 is 5, and g to the third times g to the second. Here you have 3 g's, here you have 2. That is a total of g to the fifth. And that's what you started with, so you know you have factored correctly. Does that make sense? Because it's just the reverse of the distributive property. Any questions on that? Okay. Excuse me. Let's take a look at letter B. So we have coefficients of 2x to the third plus 6x squared plus 8x. What is my smallest coefficient here? 2. All right, so that means I'm going to start with 2 is, obviously 2 is divisible by 2. Is 6 divisible by 2? Excuse me. Yes, because it's even, and 8 is also divisible by 2. So we're going with 2. And why do we always start with the smallest one? Because we want to see, obviously you can't start with a larger one because that's not going to divide into the smaller one. So you always start with the smallest. Then I have x to the third, x squared, and x. What's the most number of x's I can factor out? 1, right? Because this is x to the first. So I divide by x to the first. And so this is my greatest common factor. And that is going to be my first factor. And I'm just saying all of these are the same. That is your GCF right there. But we're not done. We are factoring all of this now. So then I look at this division. 2 divided by 2 is 1. X to the third divided by x leaves me with how many x's? 2. X to the second. Because you had 3 that were being multiplied. You're dividing by the 1, so you're left with those 2. Plus 6 divided by 2 is 3. X to the second divided by x. How many x's do I have left? 1. X to the second divided by x. And lastly, plus 8 divided by 2. That gives you 4. And x divided by x. That's going to cancel out and be just a 1 left over. So that's your answer. So the whole factorization of that problem above is 2x times quantity 1x squared plus 3x plus 4. What do you think? This isn't too bad, is it? Okay. All right, let's take a look at C. We got 2 more, and then we're going to call it a day. So we got 6x squared minus 18x plus 21. My smallest coefficient is 6. All right, so let's do 1 and 6. Always start with 1 and the number itself. 2 and 3. And I can't do any more because 3 would be the next one. That's already on the right-hand side. So does 6 divide evenly into all of these numbers? No, it doesn't divide evenly into 21, right? Okay. Whoever's got the music on, you need to turn it down. Really, you should turn it off. Then we've got 3. Does 3 divide evenly in 6? Well, yeah, it's a factor. How about into 18? Yes. How about 21? Yeah, so that is the largest of the factors we have. So let's divide by 3. Now, I see I have an x squared. So I need to check, do all of them have x's? Do they all have that variable? No, so it's not common to all, so I can't even divide by that x, right? So this is your greatest common factor. That's your GCF, and that becomes your first factor out in front. Now let's divide and see what we have left. 6 divided by 3 gives me 2. You've got x squared. You're not dividing it by x, so you still have those 2 x's. Minus 18 divided by 3 is 6. And you have an x left there. And 21 divided by 3 is 7. So we can factor this down a little bit more, but we haven't learned that yet. We're just going with greatest common factor. So for us, this is the final answer. Questions on that? All right, so this one's got 2 variables. Could be doable though. So let's see if you can try this one on your own. You've got 12 and 8. Think to yourself, what do I want to look for first? I want to look for the smallest coefficient, and that's going to be 8. So you list its factors, 1, 8, 2, and 4. Start with that, and then see if you can factor that all the way down, okay? What do you mean? Well, they have to be factors. It doesn't, no. I just always start with 1 on the left and then the number itself on the right, but you could easily just say 8 and 1, 4 and 2. I like that they either go in order one way or the other though, because you want to make sure you haven't missed any factors. That's a good question. So see what you can do with this. So we're looking at 8. Ask yourself, start with the largest, is 8 going to work? If not 8, will the next largest factor work? Then what variables can you divide by? Are you passed? You have 2?
No.
What's this?
Homework.
Oh. Let me see your homework.
I'm not done.
No, I know. I'm just looking. So be careful here. So you don't have to factor the whole thing here. It just says find the GCF. But 7 is not your GCF because you've got x's here and y's. So as you look at the x's and y's, how many x's could you take away from both?
2.
And how many y's?
3.
So your GCF is really 7, x to the second, y to the third. That's your greatest common factor. Does that make sense? All right. How are we doing? Well, can I do it up here? Okay. All right. Did we make some progress? Did you follow the procedure? Let's see. So, as I have 8, that is the smallest of my coefficients. And does 8 divide into 12 evenly? No. 8 times nothing gives you 12. Well, it'll be a fraction, but we need whole numbers, okay? So then we look at 4. Well, yeah, 4 is a factor of 12, so 4 is what we're going to try, and that works. And then you see you have an x, and you have 1x here, and you have 4 over here. So how many can I factor out or divide out? 1. So that is x to the first. And I have a y to the third and a y to the first. How many y's can I divide out from both of them? Only one. So that is 4xy. And remember, it has to be common to both. So this is your greatest common factor. This is my GCF. And again, you have to be careful in what they're asking you. If they want the greatest common factor, you only write that one factor. If they want you to factor the whole thing, then you need that greatest common factor first, and then you also need to divide. So when I divide, 12 divided by 4 is 3. X to the first divided by x to the first, that cancels out to be just a 1. Y to the third divided by y, how many y's do I have left? 2. Y to the second. And plus 8 divided by 4 is 2. X to the fourth divided by x is x to the third. And y divided by y, there are no more y's left. So this is your final answer. And if I wanted to check quickly, distribute it going the other way. 4 times 3 is 12, x, y to the third. Yep. Plus 4 times 2 is 8, x to the fourth, y. Yep. So you know you've got all of your factoring correct. Any questions? Okay. All right. So homework. You can do homework number 1. Probably can't do a whole lot with it, but you can get started with it. This is not due until Thursday. So tomorrow we'll do a little bit more with greatest common factor. Wednesday we will factor by grouping. Okay? All right. Good job today, guys. Seemed like you were following along really pretty well. Okay? All right. Yep, just put it there. There is another weekly Canvas activity. I do need to add it to the mix. You can also, if you have not done the one for November 3rd, that is still open too. So let me see if I can add that really quickly.